Hello everyone, let's continue with our class. So let's jump to our app. And today we're going to discuss heats of combustion. So imagine that you have a fuel, in this case sugar, and the minimum formula is going to be C12H22O11 plus an oxidizer, which is going to be KClO3, that is going to give me as a result CO2 plus H2O plus KCl. Okay, so this molecule is fuel, this molecule is an oxidizer, and first and foremost we need to make sure that the reaction is balanced. So we can see that clearly it is not, and I'm going to give you the result just for make things a little bit more agile. Okay, so I need 1 mole of sugar, 8 moles of the oxidizer, which is going to give me 12 moles of CO2 and 11 moles of H2O and 8 moles of KCl. Now, how can I say that this is going to be a combustion reaction? Well, because I am releasing CO2, okay? And usually when you release CO2, that means that you're having a combustion. The most common oxidations in combustions that you will usually find is with oxygen as an oxidizer, right? But today we're going to use this molecule. In your next homework, I want you to give me the name of that oxidizer, okay? So when you perform this reaction and you add 2.67 grams of sugar and 7.19 grams of the oxidizer, what you will have is that the system will release, that's why the negative sign, 43.7. Sorry, give me a second. You will release minus 437 kilojoules of energy. Very well. And the question of the problem, it's determine the change of enthalpy, or the heat of combustion, in the reaction if the rate is 1:8. Okay, so what does this mean? What does it mean? That we need to find the change of H if the ratio is 1:8. Well, basically what the question of the problem is asking us is to figure out how much energy is going to be released if I have what? 1 mole of the fuel and 8 moles of the oxidizer. And how are we going to figure that out? Well, first of all, what we need to do, right, is to figure out which is going to be our limiting reagent. Very well, so let's go and jump to that. So I know that 342.3 grams over mole is going to be the molecular weight for C12H22O11. Very well. And I also know that 122.5 grams over mole is going to give me the molecular weight for KClO3. Well, very well. So with this in mind, I will find out that these 7.19 grams are going to give me 0.0587 moles of the oxidizer. And I'm also going to get 0.062 moles, right, if I use this relation between grams and moles. So what are we going to do to figure out who's the limiting reagent? Well, we have already discussed that, right? I'm going to multiply this by 8 and I'm going to multiply this by 1, and clearly we can see that this one is going to be our limiting reagent. So the rate, right, of the energy of the reaction is going to be dependent on whom? Of the limiting reagent. That means, oh sorry, I made a mistake, it's 43.7 kilojoules. So the rate is actually going to be a function of what? Of the limiting reagent. So the release of 43.7 kilojoules are going to be inside of what? Of 0.0587 moles, right, of my limiting reagent. Now, unfortunately, we do not have a 1:8 rate, right? And we need to transform that into 1:8 rate because that's the question of the problem. So basically, what we have to propose now is that the reaction depends on whom? On this 8. So I'm going to need 8 moles to multiply by the rate, right, to figure out the change of enthalpy of the reaction. Very well. So if this is true, right, the rate is going to be this number. So if I multiply 8 moles times minus 43.7 kilojoules over 0.0587 moles, right, I'm going to get a number. But first, let's analyze the dimensional analysis. So this is what? 8 moles according to what? To this 8. And the problem is asking me for the enthalpy of the reaction. So this 8 is going to be related to the whole energy released by the system. So that's why we have an 8 here. Now the analysis is going to cancel moles with moles, so we're doing something right. And at the end, what do we want? Kilojoules. Why? Because we are looking for the total energy of the system, and that is important. That is why we're multiplying by 8. Sometimes these problems are a little bit confused because it's difficult to understand what they are asking from us, okay? And once we have discovered what they actually want, it's easier with a dimensional analysis to solve the problem. So let's go immediately, perform the multiplication, and what we will have is that we will release 5960 kilojoules of energy if we had what? 8 moles of KClO3 and 1 mole of C12H22O11. And this is our final answer. So going back, what we have to do is to find this energy using as reference these grams and this number of moles. If I have what? An 8:1 relationship or an 8:1 rate. Okay, I hope that this has been useful for you, and I'll see you next video.